People, due to inexperience, apply a layer that's way too thin and it just sinks in when you press it with your finger. Either it's all uneven or there are some drips and runs there. If you want to finish the project on time and avoid problems, it's better not to get involved with this. I couldn't get anything to work. We picked out a bunch, about 20 different shades, and added some reflectivity and matched it perfectly. They pulled the handle, it moves a little, hits the edge of the opening, and the insulated glass unit cracks. You need 4 strips for one window. That's already 100,000 just for the strips, the ones that are simply glued to the frame. Hey guys, hello everyone. Today I wanted to tell you about structural glazing, the nuances, what technical solutions there are, and so on. First of all, I want to say that there is an option called so-called frameless glazing. Some people call it that. This is when insulated glass units are installed directly into the opening, like in a half-timbered house, into the wooden beam, or some craftsmen install all of this into foam blocks or aerated concrete blocks, somehow fitting the glass units in, sealing and insulating them. We are not talking about that. I don't use that technology. In my opinion, it has its own drawbacks, so we are not discussing it. Secondly, there is another technical solution. These are insulated glass units with increased rigidity, sometimes called carbon glass. For example, the company Thermoglass produces such technologies. I have implemented such projects myself. I even have a video about it on YouTube. This is when the insulated glass unit uses special fiberglass spacers between the panes instead of aluminum ones. These are carbon spacers. And there is a special sealant used there. Thanks to this, it is possible to achieve high rigidity at the edge of the glass unit, and there is no need for an aluminum profile. That is, you can simply install 2 insulated glass units like this, and the glass unit itself absorbs wind loads, it doesn't bend, it's rigid enough, and so on. Of course, these insulated glass units are quite expensive. However, in some cases, the use of this technology is justified. We're not talking about that today either. We're specifically discussing standard classic structural glazing, where aluminum profiles are used and insulated glass units are installed into them. Accordingly, there is a mullion transom structural system. The idea behind it is that in a typical mullion transom system, we assemble the frames, the mullions, and the transoms. In a structural system, we assemble the frames, mullions, and transoms in exactly the same way. These are the load-bearing elements that support the weight of the glass, wind loads, and so on. Once the frame is assembled, the insulating glass unit is installed from the outside, and in the classic system, it is pressed in with a pressure bar, and a decorative cap is placed on top, a visible aluminum element on the exterior. But in the structural version, this is not the case. Here, the glass units are attached using a structural method fixed at the edge of the glass unit. How does this work? First of all, the manufacturing technology of the glass unit is different because a standard glass unit uses a polysulfide sealant, while a structural unit uses a silicone sealant. This is because polysulfide is susceptible to ultraviolet radiation and must always be covered by a profile. It cannot be exposed to open air, but silicone can. It withstands all that ultraviolet radiation, sunlight, and so on. That's why silicone is absolutely necessary here. That's the first point. Silicone itself is already more expensive. The second point is the depth of sealing. In a standard insulating glass unit, the sealing depth is about 4 to 6 millimeters, whereas in a structural glass unit, the sealing depth is approximately 18 to 20 millimeters. This depends on the size of the glass unit, what kind of inserts are used, and so on. Well, that's about it. In other words, a fairly large amount of silicone is required, and the sealing depth is significant. Such a large sealing depth is due to the fact that an embedded profile is inserted there, which will later be used to press the glass unit against the mullion transom system. Often these are aluminum profiles inserted in U-shaped pieces. That's how it is in many systems. In Alutech's new structural system, which I think came out last year, these are plastic small pockets about 100 millimeters each, so to speak. Plastic pockets that are glued in there into this sealant. There, it's absolutely necessary to position it correctly during production. Templates are needed because if it shifts in the sealant, then the insulating glass unit won't be properly pressed in later. So, accordingly, we ordered these structural insulating glass units. Their price is really much higher than regular ones, about 50% more, sometimes even higher. So that's basically why structural glazing is so expensive. And accordingly, it's due to this sealant, these embedded parts, and the complexity of manufacturing. Let's say our insulating glass units have arrived, we install them in the mullion transom system in the same way. Then we secure them with so-called helicopters. And these are little parts like this. They used to be made of aluminum in Alutech, and in many systems they are still aluminum. Now, in Alutech, they are plastic and you need a special key to turn them like this. So we use this long key to install 2 panes of glass, insert the helicopter in there, turn it, and it goes into the embedded part of the glass unit. Just like that it goes in, and then we screw in a self-tapping screw. Accordingly, these helicopters hold our glass in place in a concealed way. So it's way in there, deep inside at the joints of the glass units. That's where the helicopter is, holding the glass unit in place. Next, after we've pressed the glass units together with these helicopters, we insert foam insulation in there and then we seal the joint. The joint between the glass units ends up being 20 millimeters and a special structural sealant is used. This could be Dow Corning or it could be Kartlinger 995 or Sika. There are many different sealants used. The main thing is to have a good proper sealant. That's the first thing. And secondly, you need people, specialists who can apply and smooth out the sealant neatly. Because I've had all sorts of situations, sometimes due to inexperience, people apply a layer that's way too thin and it just sinks in when you press it with your finger. Or it ends up uneven, or there are drips, scuffs, irregularities, and so on. In other words, when everything is in place, there are very few people who can make the structural joints look neat and attractive. So if your installers don't have experience working with structural joints, it's probably better to contact the sealant supplier or look for specialists, maybe on Avito or somewhere similar, right? There are quite a few of them who, for a separate fee, will come and seal everything neatly. They have their own techniques for doing this. They use painter's tape, go over it with a spatula. Then some use a sponge with soapy water to smooth things out. Others sand down any excess with fine sandpaper. So, all of this is a very meticulous and challenging job. Well, that concludes the installation of the structural glazing, specifically the facade part. If we're talking about operable elements that are integrated there, for example, if you don't have fixed glazing but instead have a window, a door, a folding system, or sliding panels integrated, something like that. A window can be made structural, a door can be made structural, I've even made a folding system structural, and I'll show a short video here on the screen of how we did this at the Luzhniki project. It's impossible to make a sliding system structural. Specifically, it's impossible to make a classic sliding system like those from Alutech or Schuco structural. But, for example, the company Thermoglass presented a sliding system on a magnetic cushion at Mossbuild in 2025. It's a really cool, well-designed system, and they can be quite large in size. And this is based on those insulated glass units I mentioned earlier with increased rigidity and these carbon spacer frames. In short, they created a sliding system that is basically just glass that moves. That is, you don't see any aluminum profiles there, they're essentially not present. And if you need to use structural glazing at your site and you want the sliding system to be structural as well, then at the moment, technically, the only option is to order this thermoglass system or accept that everything will be structural except for the sliding part. Next, let's talk about structural windows and doors. There are a ton of nuances there. Let's say we take a window frame. For the sash, the opening part, you simply make a glass unit with these extensions, with a notch. The outer glass has this so-called notch and it is glued into the sash. But as for the frame needs to have these strips of glass. And here, accordingly, a whole bunch of nuances arise. With doors, it's basically the same, a sash with a notch, strips of glass. With folding doors, it's the same, a sash with a notch and strips of glass on the frame. So what are the nuances here? I have a lot of experience with all of this. I've already been through all of this many times, including the mistakes and the problems that come up. Accordingly, if we use multifunctional glass, meaning soft coating, there are actually two types of coatings, soft and hard HD. Multifunctional glass, which provides both sun protection and energy saving, in other words, a kind of double effect, uses a soft coating. HD coating, which is hard, is only a sun protection coating. In other words, it provides sun protection, but it does not offer energy saving. Accordingly, for structural glazing, when everything is glued onto the sashes, I now use only HD coating and recommend everyone do the same. There are some nuances to this. Why? Because if we take, for example, soft coating, then at the factories that produce these insulating glass units, the edge and the strip of glass need to be painted. With soft coating, you can't paint directly over it. This coating has to be removed first. And then accordingly, painting was done. So the removal of this coating can be done by very few companies, just a handful. In my experience, it was hit or miss. One time they did it properly. The next time I received an insulating glass unit with a spacer, and on the outside of the spacer you could see these stripes. I'll show you a photo right now. These are stripes from the grinding wheel that removes the coating. So if we're talking about a soft multifunctional coating, you need to understand that in order to paint it properly, you first have to remove this coating and then accordingly paint it. And when the coating is removed, these stripes appear, which can show through after painting. So why would you want these scratches? We rule out this option. In other words, we do not remove the coating. The second option that manufacturers suggest for soft coatings is blackening with sealant. That is, we leave the coating as it is and then start covering it with sealant. So the problem here is that when we leave the coating and cover it with sealant, these edges don't turn black. They take on a golden tint, because this coating gives a kind of mirror-like effect, a slight golden hue. And as a result, you get these golden-looking edges along the perimeter of the glass unit, which doesn't look very nice. That's one thing. Secondly, when it comes to the glass unit, for example, sashes with a lip, if you seal them with this sealant, that's also not good. There are a lot of flaws. Some areas aren't sealed properly. There are bubbles and excess sealant builds up. Then, when you start gluing this glass unit into the sash, it sticks out in some places because there's more sealant than necessary, right? In other words, it's not a thin layer. There are these buildups. I've actually ordered glass units like this before, so I have experience, and the factories had to redo them 3 or 4 times for me. I couldn't hand over the projects for half a year because I ordered glass units with blackening with a step, and they kept arriving defective, defective again, and again defective because it's all done by hand. That is, at the factory, a person takes a spatula and starts smearing the sealant like this. And accordingly, wherever it's done by hand and not on automated equipment, the likelihood of mistakes is much higher. That's the first point. So blackening with sealant, well, we avoid it because, as I said, there's the goldish tint plus sealant overflow, unevenness, and a high number of complaints and defects. If you want to finish the project on time and avoid problems, it's better not to get involved with this, because there will definitely be issues here, constant rework. You'll be constantly filing complaints and waiting for new glass units. I'm telling you, they redid these glass units for me 5 times. I couldn't hand them over to the client. Everything was done except for the door. I can't hand over the structural door because of this. The second issue is the glass strips. So, while we can do blackening with sealant on the glass unit, no one will make thin glass strips with soft coating for you. These manufacturers simply won't do it. They won't blacken them with sealant, they won't cut them, and so on. What did I have to do? I took the sash and did the blackening with sealant myself. Well, that was my experience. I'm not saying it's the right way, it was just my experience. I did the blackening with sealant. Then, accordingly, I ordered the strips somewhere else from regular glass without coating. Then I took them to be painted and thought that I would take the sash with a glass unit that had a golden tinted edge and match the paint for the regular glass strips. So I figured there would be a single shade, but nothing worked out for me. We tried a bunch of options, about 20 different shades, added some mirror effect, tried everything you could think of. Because there's a layer of blackening sealant sprayed onto the edge, this coating gives such a unique golden tint that it's impossible to match the color of the strip. In the end, I had to use a black strip, so there's a golden edge on the sash and a black strip on the frame. Basically, it turned out okay, but not great. It could have been better. These are the problems with soft coating. That's why I moved away from using soft coating. So when I have structural glazing and need structural operable windows, doors, sliding systems, or folding doors, I specifically use glass with HD coating there. What's its advantage? It's that insulated glass manufacturers can paint it without removing the coating. There's no need to blacken it with sealant. And because it's hard, they can immediately paint the edge of the glass for you right on professional painting lines. And they can even make this strip and paint this strip as well using the same coated glass and paint it too. So they have that capability. We implemented such a project at Luzhniki. These are glasses like, for example, Silver 32, Silver 70, right? Well, there are different shades, different names, but mainly it's this multifunctional type, like neutral 6040, that's multifunctional when you have 2 numbers, right? There is 60.40. When you have just 1 number, it's most likely HD coating, but it's better to double check. That's it. In this case, we end up using a sun protection glass on the outside and an energy-saving glass on the inside. But if it's a double-chambered insulated glass unit, you can install 2 energy-saving panes, and it will be just as good as with multifunctional glass. Moving on. We agreed on the glass, ordered double-glazed units with a notch from the factory with painting done on automatic lines. And we also ordered strips from the same glass, painted on these automatic lines. This way, everything will turn out perfectly. But there are some nuances. The nuance is that these strips won't be very long. They can be made up to 2 meters. Accordingly, if you have, for example, a door that's 3 meters long, then it will be a joint made from 2 strips. But that's still better than making a single solid strip separately, not from this glass, without the coating, which would then differ in shade. These were exactly the problems I encountered when I was implementing all of this. Next, we ordered these double glazed units, and we also ordered the strips that are glued onto the frame. All of this arrives at the workshop. You bring it to the workshop. At the workshop, the sash is manufactured. Then accordingly, we degrease it. There are special primers for this. We wipe it down and degrease it. After that, you buy 2mm double-sided tape. And I buy all of this from the company SDM Kimia. There is double-sided tape, and there is a special adhesive that is used to glue everything together. They have conducted tests there, and they guarantee that everything will hold. So accordingly, we apply the double-sided tape where the strips are, where the sash is, we stick it all on, and then accordingly, we insert the insulated glass unit there. And of course, we apply the sealant. This is a special adhesive. Then we glue in the insulated glass unit and attach these strips. What have I encountered, and what nuance have I noticed? For example, before, when we used to glue it in, we tried to apply this double-sided tape along the edge of the glass. And when we glued in the glass, it turned out that you could never stick it perfectly. And somewhere it would either stick out from the glass or, on the contrary, sink in. So from the end, the edge didn't look very nice. I moved away from that, and now I asked the production team, we made drawings, developed everything, for them to stick this strip of double-sided tape about 3mm deeper so that the entire edge is taped. Then, inside, between this strip, they specifically apply this glue. All of this is glued in, allowed to dry, and then the edge, where there is a 2mm gap between the profile and the glass, is sealed right along the edge with structural sealant. And as a result, if everything is done neatly, you get a very nice edge, a finished look, no double-sided tape sticking out or anything like that. You end up with a really neat edge. I definitely recommend doing this. Of course, in this structural glass, you need to provide holes for the handle, for the lock, for the cylinder, and so on. As for installing various handles in this kind of structural glass, first of all, the holes there for the handle, make them larger in diameter, because I had problems when I made them really tight. The handle was pulled, it played a little, hit the edge of this hole, the glass unit burst. So make the hole larger in diameter. Be sure to bevel the edge of the hole. Include all of this in your order form. Blunting, beveling, basically make sure the edge is finished as much as possible so there are no microchips. So, moving on. To prevent excessive pressure on the glass, you also need to apply double-sided tape around each hole at the factory. And I order special plastic bushings. There's such a thing as 3D printing. So it's all inexpensive. We designed these little bushings for each handle, depending on what kind of rod or push handle set you have. I use these everywhere. 3D printed spacers that, first of all, allow me to protect the glass from things like studs, screws, and so on that go in there. Secondly, they transfer the stress from the handle directly to the profile, bypassing the glass. Nothing presses on the glass anymore because there is this 3D printed spacer between the profile and the handle. So we make these spacers and screw everything in there. And basically, that's how you get structural glazing. There are certain nuances when it comes to doors. If we use roller hinges, then accordingly, you'll need to mill out small grooves along the edge of the glass, but that's also manageable and can be done. If we use concealed hinges, it's essential to bevel the strip that's at the edge of the frame, and you need to check exactly how the hinge opens so that it doesn't catch on anything. If you don't bevel it and just use straight glass, which we've also done, the gap between the glass panels ends up being not 5mm as it should be, but 12. This is to ensure that when the sash opens, it doesn't catch on that strip on the frame. If we do a bevel, then you can shift it. There's about a 7mm gap, I think. And because of the bevel, it opens without catching. So these are the kinds of nuances specifically related to doors. With windows, since they open inward, there are no such nuances. There are no such nuances on accordions either. We've been through all of this. There's another point. I made vent sashes for structural glazing. A vent sash is this solid aluminum sash. There are 180 and 280 sizes, usually used in large glass facades with a vent sash somewhere on the side. Accordingly, the vent sash can also be made structural. There are technical system solutions from Alutech, but I don't like them. Why? Because with their solution, the glass is only glued to the sash while the frame remains without glass. And that's unattractive because you can see the frame profile. If we want to create the effect from the outside that everything is glass, then we need to glue glass everywhere. So on the vent sash, we end up with a strip of glass on the sash and 4 strips of glass glued to the frame. That's it. And as it turns out, this is actually quite difficult to do, but we managed to do it as well. And you can use the same type of glass here, preferably, right? Here you can actually use regular raw unpainted glass. What's the difference there? Let me explain. There, this effect just won't be as noticeable as it is on a window or door, because in a window or door we have a transparent section. You see? We have a transparent part, then a notch, and then a strip. And it's important that all of this matches in style. But when we have a vent sash, we end up with a double glazed unit and then everything else is solid aluminum. So in that case, it's not necessary to use this coated glass and you don't have to stick it onto the sash. Why is that? Because it goes up to 2 meters. But if our vent sash is more than 2 meters, say 3 meters high or even 3.5, then we'll have to make joints for these strips again. Instead of 5 strips on the sash, we'll end up with, well, 3 more strips added. So there will be 8 strips on the sash. I don't know how that's going to look, honestly, but to me it seems like quite a hassle. That's why in cases where the vent sash is over 2 meters, I try to use regular strips. This is raw glass, and those manufacturers who make large insulating glass units, the ones operating on an industrial scale, they don't make long strips. They can only go up to about 2 meters. But there are companies that specialize more in things like mirrors or interior glass, and their equipment isn't so large scale. They can make small strips like 40 millimeters wide. For example, I had a 40 millimeter strip made that was 3 meters 20 centimeters long. A single solid piece, you see? And they can make it as a single piece with polished edges too. By the way, this is a very important point. In all these structural elements, whether strips, insulating glass units, or teeth, the edge must be polished because it's visible, right? So it's not just grinding, it has to be actual polishing. So accordingly, I ordered these separate strips of raw glass from such factories, long, thin, with polished edges. Then I would take them and we would paint them. There are also special painting facilities that can handle all of this. And after that, we would bring them to the workshop and glue them. There are some nuances there and you end up facing a lot of problems. I'll show a photo of what this structural vent sash looks like with the glass strip attached. It turned out amazing, but I ran into a lot of problems. First of all, sometimes the sealant seeps through this paint. You can actually see the lines of the applied sealant that the strip is glued with. They show through the paint. That's why we made the decision to repaint. We would make the glass strip, paint it, and then apply an additional protective lacquer coating on top so that the sealant wouldn't seep through or show. So you really need to paint all of this well. And painting these strips isn't easy either because you have to protect the edges. On the edges we have polishing and slight bevels, chamfers. And it's important that the paint doesn't get on those areas because it would look bad. The paint should only go on the surface that's being glued. So there was a whole story with the supplier. The person who did the painting really, well, he worked out this technique together with me. It was quite difficult, but we managed to do it. When we attach these strips, we realize one thing, because the sash is very narrow when you open it. If it's a door, it opens outward and catches near the hinges, but here the sash opens inward, and the glass that's glued directly onto the sash catches and hits the frame. When we have a large structural window, this problem doesn't exist. Specifically, with a window that opens inward, you don't need to make a bevel there. But when we have a very narrow vent sash and such a small turning radius, you need to make a bevel on the glass that's on the sash, on the handle side. That's it. So we made those bevels as well and had to reattach some parts there. So we called in glass polishers on site and they made the bevels there. In other words, we really struggled with this. But once we made those bevels, everything closed properly. And as a result, you get a vent sash that's completely glass on the outside. You definitely need to think through how it will be attached to the mullion transom system, because since it's on the outside, it's usually fastened to the mullions from the outside. But since you have glass strips on the outside, you can't fasten it that way anymore. You need to fasten it from the inside. And to fasten it from the inside, you need to make sure that either it lines up with the mullion, or you need to install these aluminum compensators, these spacer elements, so you can screw into them. This point is important too because we didn't account for it. Our self-tapping screw didn't reach the mullion, we couldn't catch on to anything from the outside, and as a result with the glass we couldn't screw it in. So we had to replace the plastic compensators with aluminum ones and fasten them with self-tapping screws and then attach the sash to this compensator. If you don't fasten it, the frame starts to flex, bending like this when you close it, especially where there are concealed clamps. It starts to spread apart, gaps appear there. In short, it absolutely needs to be secured properly. So basically we ran into a whole bunch of these little details. Now, the next nuance is drainage. Since on structural products the glass is glued on from the outside, you need to think through how the drainage will be handled. If you have the option to make it hidden, for example, if you have some kind of drip edge at the bottom or a base profile and so on, if you can make the drainage hidden, do it that way. Then you won't need to make any holes in the strip. But if, for example, your product goes all the way to the floor and the floor comes up on both sides, and you need to provide drainage but can't make it hidden under the frame, then you need to make drainage holes in the bottom strip that is glued to the window frame. That is, you need to mill out round or oval or elongated holes to allow water to drain. In other words, make drainage holes. So this is another detail you need to think through. In short, I can say that I've already redone a ton of structural work. Windows, doors, vent sashes, and folding doors. And well, I've really learned the hard way. I truly understand all the nuances now. I've drawn a lot of conclusions and gained experience. And we've already completed more than one project with structural glazing. Now there are more and more requests for this. People are willing to pay for this kind of beauty when there's absolutely no aluminum profile visible from the outside. And we also do it so that the glass, the finishing, comes right up to the sealant next to the glass. So it all turns out so cool that from the outside you just don't see a single aluminum profile at all. Can you imagine? It looks absolutely stunning, really awesome. So accordingly, but honestly, it costs about twice as much to do all this compared to regular glazing. So you need to understand this. If you want, say you have a house project, you've calculated the glazing, and it comes out to 5 million, for example. If you want structural glazing, you can safely double that amount. Of course, if there's a lot of fixed glazing, the difference will be a bit less. In that case, the difference will probably be around 30%. But if there are a lot of operable elements, all these windows, structural doors, and so on, then it will definitely be more expensive. Because you see, even a small 2-meter strip of glass, just 50 millimeters by 2 meters, manufacturers price a painted strip like that at 20 to 25,000 per strip. Just imagine, for example, you need 4 strips for one window. That's already 100,000 just for the strips, which are simply glued onto the frame. And for the sash, you also need to make a painted glass with a notch. That's also more expensive than usual. Then you have to bring all this to the workshop and buy a bunch of consumables for gluing. In the workshop, this needs to be glued in, and the workshop also charges quite a bit because it's manual work. It takes a long time. It's not like mass-producing products. So they glue all this together, and then it has to dry for another 4 days. After that, everything needs to be packed very carefully so that, God forbid, the edges of the glass don't get hit anywhere. Otherwise, it's re-gluing, redoing, and so on. So all of this comes with its own challenges. Plus, adjusting these kinds of sashes is very difficult because you can't pull the diagonal like you can with a regular one. You can't tweak it by adjusting the glass unit. Here, you can't pull anything anymore. Everything is already fixed, so you can only play around with the hardware. The installation must be perfectly level in all planes. Otherwise, if something doesn't align somewhere, if anything is crooked, you won't be able to fix it anymore. There's a lot of responsibility here during design, production, and installation. All specialists involved must have the highest level of expertise. That's it. I hope this video was useful for you. Write your questions and comments and give a like. That's it. Goodbye, everyone.